So welcome everybody this morning from sunny Cyprus to this workshop on industry and open science being organized by the OPUS Project and also by our colleagues at the University of Cyprus. This is predominantly an online event, but as you can see here in one of the videos, we also have some colleagues at the University of Cyprus. So I don't know if they all want to give us a wave there, but welcome also to all of you there in Cyprus. I'm going to pass the floor very quickly to my colleague, Marius. Marius, do you want to introduce yourself very quickly and say hello and welcome everyone?
Hello, everyone. I'm Marios Dimitriadis. I'm the Director of Research and Innovation Support Service here at the University of Cyprus. I want to welcome the colleagues that have traveled to Cyprus and the university to be here with us. It's a privilege and pleasure to have you here. Also, the colleagues that have been connected online to this to today's workshop. Here at the university, it's been a few years since we started our transformation journey in research and innovation, and OPUS, our project, has been one of the main fuels that we have used to drive towards a better, fairer, and open research horizon. So we consider open science to be the key underlying foundation for achieving this vision of strengthening research results, having them utilized by both academia and industry, and also enable researchers to build a career in both sectors. So throughout today's workshop, we'll explore real-world examples of how open science and open innovation are shaping today's world and industries, and how they are fostering collaborations that push the boundaries of knowledge and what's possible in general. So it's not about theory today. We will see practical, actionable steps that will help us navigate and strengthen this cross-sector integration in research. So I wish you all a great workshop today. We really look forward to hearing to our speakers, and thank you very much again for organizing this and being here with us today. Thank you.
Thank you, Marius. Okay, so maybe just a couple of points before we start. First thing is we are recording this just so you are aware. So the video is being recorded for internal purposes. Secondly, we do aim for an interactive session. So we are expecting you to hit us with some questions or hit us with some comments, either by raising your hand or by putting it in the chat. So please do engage with us. And before we start, we'd like to know a little bit about you. So let me pull up a slide, bear with me. And if you all can go to the following Mentimeter, so that's menti.com, and then you can type in the use code there, 17157790, or you can use the QR code and go straight on. Please note, we have 3 questions coming, so once you fill in the first question, hang on, there's 2 more coming. And this is where we'd like to get your input on this. So I'll just repeat that. You can already start filling in the first question, but go to menti.com and type in 17157790, or just take a snapshot with your camera of the QR code there, and it will automatically bring you to the Mentimeter. I'll leave that up just for a couple of seconds so everybody has it before I go to the Menti itself. And I will kill this screen in 5, 4, 3, 2, 1. Okay, and let us switch to the Mentimeter. Okay, so you're already very busy there. The first question is very simple. Who are you? Are you a researcher? Are you a research manager? Are you on research support? Are you a policymaker, or are you other? And I will give it just a moment for that number to increase. I see 52, 54 have filled in already. There we go. I'll leave it to the 55. So I think predominantly here we have a lot of researchers, as you can see. Also for our speakers, good to know. Some research managers, some research support staff, some policymakers, and a few different others. If you are some of the others and you don't mind, maybe just type it in the chat so we get an idea of what type of other you are. The second question we have here, if you can, single words only. So please give us 3 keywords that you associate with open science. I'm not going to give you any suggestions here. What are 3 words that come to your mind when you think about open science? And you can be as honest as you want. Preferably single words. If not possible, then of course double words are fine. And I'll give that a few minutes just for colleagues to fill that in. So 3 key words that you associate with open science. We'll give this a few moments to see how it progresses. Okay, so what we already see at least is very clearly sticking out here, transparency, an obvious one. Also innovation, which is interesting. That will bridge to the next question and to the topics. We see collaboration and we see open access. These are very strong there. Open access being very much linked to open science. And then we see a few others such as accessibility or reproducibility, sharing, quality, openness, integrity, open data, extra work. It can be, yes, we might come back to that a bit later. Additional work, same thing. Knowledge transfer, hot topic. That's a bit of a burn there. So definitely a hot topic for the moment. We see open source, robustness, democracy, uniformity, sharing. Okay, so quite a lot linked to openness, of course, collaboration, interaction, engagement, but some skepticism as well, as I see. And the final question we have for you, the same thing. So if you can, single words or double words, if possible, 3 key words that you associate now this time with industry. So what are 3 words that come to your head when you think of industry? And again, I'll give that a few moments. I was waiting for that one. So let's give it just a moment to stabilize a little bit. Okay, so what clearly sticks out here from a first glance is certainly profit, money making, but we also see here a bridge to the previous one on innovation. We see productivity, development, progress, innovations comes up quite a bit. We see intellectual property, application, technology. So here it seems to be much more practical focused, solutions, global markets, proprietary, again, intellectual property, state-of-the-art rapidity, translational research, engagement, impact, competitiveness. So we do see 2 different sides of these 2 different words. What we will now listen to today is how these 2 somehow interact, or how they maybe feed into each other or engage with each other, and what essentially is the link, let's say, between open science and industry. I will let that run in the background. Let me come back to my slides. Okay, so one moment. Yes. So very quickly, the OPUS project that's running this workshop, this is a European funded project for just over 3 years. We're coming into the last 6-ish months of the project now. This was a coordination and support action for around just under 2 million euros to develop what are called coordination and support measures to reform the assessment of research with a focus on open science. So the idea here essentially in the project was to see how can we start assessing researchers beyond the usual traditional hyper-focus on peer-reviewed publications, on high journal impact factors, and on the high number of publications in such journals, and instead start opening up the options and the possibilities for researchers to be rewarded and recognized for other activities. And when I say other activities, all the other activities that researchers essentially do but are typically not credited for, from beyond doing the research, from managing, curating, even publishing and sharing data, from doing research teaching or training or education, student supervision, all the different lectures, talks, conferences, non-peer-reviewed publications that they do. So trying to open this up, and then specifically trying to include actions that will link to open science. So we know that if in assessment activities are not recognized or rewarded, it's very unlikely that researchers will focus on them. So the only way essentially to help researchers open up more of their publications, open up more of their data and their workflows, is to try and support this by recognizing and rewarded in the assessment system. So this is essentially what OPUS is producing, will produce. We've already worked on a very detailed researcher assessment framework, as we call it. I won't go into that now. You can see it on the project website. But what we will see then here today is how does open science perhaps also feed into this assessment, noting that assessment, by the way, is different across the different sectors. Now, what do we mean by open science? Well, back in 2016, the European Commission came with what they call the 3 O's. The first one was open innovation. And from the perspective of the Commission, this was essentially to bring more stakeholders together and to create more innovation and deliver more products and more services to the market through this different cross-sectoral, cross-stakeholder interaction. So this is how they see open innovation, typically more focused on application, technology, and practical solutions. Open science was one of the ways that they seen to deliver this collaboration. So from the Commission perspective, open science was about facilitating open research through the use of digital tools. So bringing colleagues, researchers together through digital platforms and opening up their workflows, possibly to different levels of openness or delayed openness, or maybe not open at all, and essentially helping these colleagues work together better and to share the results so that we can get products and services and outputs quicker to the market and quicker to benefit society. The last one was open to the world. This was about opening up the borders beyond Europe, looking beyond academia or industry and more towards societal impact. It's disappeared a little bit, I've noticed, in Commission terminology, but it's still quite relevant in terms of collaboration, in terms of societal impact, and in terms of the geopolitical stasis that we see ourselves now in. Now, maybe just to conclude, to give you a little bit more flavor of open science. So typically when we talk about open science, as you've seen, we talk about open access to research publications. This means opening up the publications either already in a preprint format or in a just reviewed format or in a final publication format. So there's different types of open access. Sometimes paid, sometimes not paid. I won't go into that just now. We have the data, 2 types in principle. We have fair data, which is essentially providing adequate metadata to data sets so that machines can understand what are there and help us to find them and combine them. So FAIR here stands for findable, accessible, interoperable, and reusable data. This is different to what we call open data. Open data is, strictly speaking, any data set that has been opened, typically online, or in any case has been made accessible. Fair data can but does not need to be open, and open data can but does not have to be fair. Ideally, we would all start in an ideal world with a fair data set and then potentially open it up. There are reasons, of course, for not opening it up. That could be, for instance, for dual use technology, for military potential use of technology, for security information or data, for privacy data, for intelligence data, for biomedical data, and so forth. So when we talk about open here, we don't mean always open immediately at all stages or in all types. We really do mean, as the phrase goes, as open as necessary, as closed as possible. So you look at each different case and you see whether it's relevant or not. Open source, this is about opening up the software code for tools or software applications that are relevant for research or research instruments. Open peer review is about opening up the research publications so that you can already see at the start what will be published. You can potentially see the authors, you can potentially see the reviewers. You can potentially even see what the reviewers have said and the different versions of peer review. There's different dimensions and levels of that, which I won't go into now, but essentially you're opening up the peer review process. Open licensing is about opening up the license on a copyrighted intellectual property. There's different types. The most common one for researchers, for instance, could be CC BY, which essentially means you can do anything you want with this output, but you must cite me as the original creator. And there's different types of licenses, for instance, under the Creative Commons licenses, as you see in the slide here. The last one I'll look at is citizen science. This is essentially about engaging citizens in your research, whether that's asking citizens for input on your research or whether that's actually getting them out there to collect data for you. Think of the kids going into the fields, taking pictures of animals, helping create a whole biological ecosystem mapping, or whether that's helping machines with their artificial intelligence recognition patterns. Think of, for instance, Galaxy Zoo. Machines are quite stupid and they can't pick out galaxies. So what they do is they get hundreds of thousands of humans to click a button. Is this a galaxy, yes or no? And then very quickly with statistical algorithms, the machine learns what is a galaxy and what is not, and then they move on into more specific cases. So these are the main activities for open science. We'll see which ones may come back in our talks later today.